Ask my instructor 3.5.26. An object is dropped from a tower 400 feet above the ground. The object's height above the ground t seconds after the fall is 400 minus 16 t squared. Find the velocity of the object the moment it reaches the ground. The position function is given by s of t equals 400 minus 16 t squared. To find velocity, we merely find the derivative of position. And so velocity equals negative 32t. To find acceleration, we find the derivative of velocity, or the second derivative of position. So acceleration is equal to negative 32 feet per second squared. Since the acceleration function is a constant value of negative 32 feet per second squared, we know that the acceleration of the object when it reaches the ground will be that same negative 32 feet per second squared. So we've already answered the second question: what is the acceleration of the object when it reaches the ground? The acceleration of the object when it reaches the ground is the same as the acceleration when it's released. The velocity function, however, varies over time. So to find the velocity of the object at impact, we need to first find when is impact. To find when the object reaches the ground, we set the position function equal to 0 and solve for t. If s of t equals 0, that means that 400 minus 16 t squared equals 0. Factor the left side using the difference of two squares, and then replace the left-hand side with this new form: 20 plus 4t, 20 minus 4t. If that product is equal to 0, then we have one of two possibilities. Either 20 plus 4t equals 0, or 20 minus 4t equals 0. 20 plus 4t equals 0. If we solve for t, we get negative 5. 20 minus 4t equals 0. If we solve for t, we get positive 5. Setting the position function equal to 0, we got negative 5 or 5. We discard the negative solution as t equals negative 5 occurs before the object is dropped from the tower, and for this problem has no meaning. So the object reaches the ground in 5 seconds. And what is the velocity in 5 seconds? At that time, the velocity is negative 32 times 5, or negative 160 feet per second. So, when this object reaches the ground, its velocity is negative 160 feet per second, and its acceleration is negative 32 feet per second squared. Have a good day, and please let me know if you have any questions.